In this video, we're going to look at the first part of lesson 7.5, which is radical equations. On that, we're going to start with some simpler ones and work our way to more complicated ones, but as always, the complicated ones need to be organized visually, and that will help us understand the process that we're supposed to use. Before we start, let's just keep in mind a couple of things with radicals. You cannot take the square root of a negative number. That's the most important part of this lesson. That's the reason why all answers must be checked in this lesson. We'll have these things called extraneous solutions, answers that you do all the work right, but when you plug them in, they don't work because they're not part of the domain. Also, you can take the square root of a number. It has to be a positive number for it. So square root of a positive number underneath the radical, equals a positive number. So before we start, just to get this idea of always checking our answers, let's assume we did 7 problems and we got these 7 numbers for x: 3, -8, 10, 1, 7, 6, 4. And we're checking our answers. Our job is to plug these numbers in for x, square root of -2. Well, that's not possible. Can't take the square root of a negative. I'm to plug -8 in for x, square root of -13. That's not possible. But if I plug 10 in for x, 10 minus 5, I'm going to get the square root of 5. If I plug 1 minus 5 is -4. That one doesn't work. If I plug in 7, I'm going to get square root of 2. If I plug in 6, I'm going to get square root of 1. But if I plug in 4, I'm going to get square root of -1. So that doesn't work. The idea is when we end and we finish the problems, and let's say I get x equals 10, just quickly plug it in and check, because there will be times where you're going to get one like x equals -8 and you did no work wrong, but when you plug it in, you're going to get an extraneous solution because the domain doesn't work for it. You don't get a positive number when you plug it in. And it's kind of I'd say the opposite. Now on this one, we're looking at, okay, I have something random on the inside, but the outside's my x. So I'm taking the square root of some number and I'm getting x. Well, if I look at it again, like plugging it in here, can I take the square root of something and get a negative number? And you can't. Same thing here. Take the square root of something and get -8. It doesn't work. But square root of square root of something and getting 10 does work, because it's positive. 1 is positive. -4 doesn't work. 2 does work. What about 0? 0 is not positive, but 0 does work because the square root of 0 is 0. So if the square root is all by itself on one side of the equation and it's equal to one number on the other side, that other number has to be positive. And we learned from the other side that the inside has to be positive, which looks like this up here. This is the key to solving equations, well, checking your answers for solving equations with radicals. The expression on the inside has to be positive, and the expression you get afterwards has to be positive as well. So let's try it out. When we are dealing with this problem, on these, we're solving radical equations. Keep a few things in mind. This is just the general thought process, no matter which ones you're working with. We'll start easy and go a little more complicated. First, we need to remember we need to isolate, I'll use orange, we need to isolate the radical on one side of the equation by itself. That's the key. Use a marker, use a colored pen, or use a highlighter and put a box around it. So you see, I'm going to use a highlighter on this, and I really encourage you to do the same thing so you can see how to work with the more complicated problems. Now, the more complicated ones are when you have more than one radical. And in that case, and we'll get to this, we're going to put them on opposite sides. We're going to isolate one and move the other one to the other side. That's going to allow us to square both sides on it, and that's helpful because squaring and square rooting are inverses. They're going to cancel each other out. It will be trickier when you have more than one radical present. However, there's going to be a visual way to organize your work to make it a little bit easier. And then we solve, and just like we learned before up in here, that part we're going to make sure we have to check our answer. So we'll start with some basic examples first. In this part, and I'll try and keep the thought process visually up there so you can still see it, is isolate a radical on one side. So square root of 2x minus 8 equals 6. If I put a box, or for me, I'm highlighting that radical, that is already all by itself. There is not a single thing I need to do to it. I don't have to get it alone, it already is. So I'm going to rewrite it just so we can kind of see the original problem with our work underneath it. Now that it's by itself, I didn't have to do anything, I'm going to square both sides. I really encourage you all to do this. It's something that a lot of students don't do, and it's going to make the harder problems, the trickier problems, you're more likely to make a mistake on. I know this radical is all by itself, but I'm still going to put a parentheses around the left side, and I'm going to call it the left side, because if I had multiple things there, the parentheses would go over that entire thing. Same thing, I know you really don't need a parentheses to go on the right side because it's one number, but I'm still going to do it because that's going to train me for the harder problems. The square and square root are opposites, so I get 2x minus 8. 6 squared is 36. Now I just solve. Add 8 and divide by 2. Now before I do this, I got the answer. Before I do that, I better plug it back in and check. Now I'm going to do it by hand, but you can use your calculator as well and just type this in your calculator and see when you hit enter, do you get 6? For me, the mental math with arithmetic, 44 minus 8 is 36. Is the square root of 36 6? Yes, it is. So I am right. We are good. And I am very serious that you can check it with your calculator. And you can see right here I have it typed in. Square root of 2 times 22 minus 8, it does equal 6. So I am right. You can still check it even with your calculator. Very basic problem. The other one isn't as bad for it, but the radical is not by itself. I'm going to highlight it. I'm going to put a box around it. I'm going to use a marker or pen, colored pen, and separate it. And I look, it has this minus 7 on the outside. I have to get rid of that first. So what I'm going to do is I'm going to add the 7 over to the other side. Now that radical is all by itself on the left side. So I'm going to put a parentheses around the entire left side and a parentheses around the entire right side. The radical and the square, when I square both sides, are going to cancel each other out. So I'm left with 3x minus 2 equals 16. Now we just solve. 3x equals 18. X equals 6. So now I just have to check. Again, you can type it in your calculator. You would type in the square root. You have a 3x, 3 times 6 minus 2. There's a minus 7 on the outside. If I type that in my calculator and hit enter, I should get negative 3. And we'll see. 18 minus 2 is 16. Square root of 16 is 4. 4 minus 7 is negative 3, which is exactly what it says it is. So therefore, my answer is right. We're good. There will be times that when you check them, it does not work. But these are, I'd say, the more basic examples. And I say basic because there's only one radical. There's not two radicals. We have yet to really look at these italicized parts. So let's try it out. And first thing I'm going to do is I'm going to look at 1 and 2. They look very similar to each other. 3 and 4 look similar to each other, but something new. We haven't seen that before. Let's kind of see what happens on those. But I'm going to put and highlight this radical. It is not by itself. I have that plus 3. So I'm going to subtract 3. And that's going to give me 7 on the right-hand side. Now that radical is by itself. So parentheses around the entire left side, parentheses around the entire right side. I don't care what's written there, that's what you do. I don't care if it's one number, I don't care if it's just a radical. It's always parentheses on the left, parentheses around the right. And that's going to allow me to cancel out the radical and the square because they're inverses. So 3x minus 4 equals 7 squared is 49. And so I get 3x equals 53. And I'm going to get x equals, and yes, you would type that in a calculator and you would get a decimal. However, you're going to want to leave that as a fraction because we need to check it. And in this case, especially if I'm getting a fraction, I am going to type it in my calculator. 3 parentheses 53 divided by 3 minus 4. Outside the radical is a plus 3. And hopefully, if I type that in, I should get 10. Now, it says it's a fraction. I'm still going to do it by hand because I can see these 3's are going to cancel. And I get 53 minus 4 plus 3, which is square root of 49 plus 3, which is 7 plus 3, which is equal to 10. So we are good. So even though it's a fraction, it still works. And it wasn't bad to do by hand, but you can still use your calculator and check it. Number 2 is new in the sense it has a coefficient. But that doesn't change anything because if we put a box just around the radical, or we highlight just the radical, it allows us to see if we want to get this by itself. We do the same thing we've been doing. We're going to get rid of that minus 7 by adding 7 to both sides. But the problem is now that radical is not by itself. That 3 is a coefficient. So I'm going to divide by 3, and that's going to cancel it out on the left there. But I also have to divide by 3 on the right side to keep the equation balanced. So I get square root of 4x plus 5 equals 6. Now that the radical is all by itself, parentheses to the left side, square it, parentheses to the right side, square it. The parentheses, well, the square and the square root cancel each other out. We're just left with 4x plus 5 equals 36. Subtract the 5 and divide by 4. And again, look at that, a fraction. Again, you could type it right in your calculator. We need to check our answer. And I'm not asking you to do it by hand. You can just type this exactly in your calculator. Minus 70 outside, and it better say 11. If it doesn't say 11, just check your work. But most likely, if it doesn't say 11, you have an extraneous solution. So if I look at this one, I'm going to do it by hand because the 4 times 31 fourths, the 4 and the fourths are going to cancel. And so I'm going to get 31 plus 5 in the radical, which is 36. Square root of 36 is 6. So 3 times 6 is 18. 18 minus 7 does equal 11, just like it says. I am good. We have the right answer. So there are your radicals for it. Now, 3 and 4, those are a little trickier because you see you have one radical, but an x on one side and x on another. And you think, well, we haven't done one like this before, but we've done it. We've just had numbers like 7 here. We've had numbers like 8 here, or like 9, or like 4. I mean, we've had numbers there before. We've never had a variable there before, but variables are used to represent numbers. So I wonder if we apply the same concept as above. Is the radical isolated? Yes, it is. So I put a parenthesis on the left side and square it, put a parenthesis on the right side and square it. And let's just see what happens. The square and square root cancel each other out. I get 3x plus 4 equals, well, I don't know what x is, so I'm just going to write it as x squared. Now, usually here, this is when we solve. But we don't usually have a square term. But it is a square term, which means it is a quadratic. And to solve a quadratic, you want to make sure it equals 0. Now, one thing I like to do is I like to make sure that the x squared is positive. So when we're dealing with this problem, I'm going to take, even though you're moving more than one term, I'm going to subtract the 3x to move it over to the right side, and I'm going to subtract the 4 to move it over to the right side. Because I like to keep my x squareds positive when factoring. So 0 equals x squared minus 3x minus 4. So now we have it set up to factor. So we want something that multiplies to negative 4x squared and it adds to negative 3x on it. So x squared, I'm putting it in the top left. Nothing combines with it, negative 4 in the bottom right. And what multiplies to negative 4x squared and adds to negative 3x? I think that is a negative 4x and a positive 1x. So I'm going to put a plus 1x here, minus 4x here. See, factoring the top row has a GCF of an x. X times x gives me x squared, x times negative 4, and a positive 1. So I get x plus 1, x minus 4, x equals negative 1, x equals 4. And you're tempted, because this was a lot of work, to just box them and stop. But you need to check your answers. We need to plug them in. And I'm going to do it by hand so you kind of see what's going on. We have the square root of 3x plus 4. So 3 times negative 1, so I have negative 3 plus 4 equals x equals negative 1. Does the square root of 1 equal negative 1? And this was what we talked about in the beginning. After you take the square root of the number must be positive. And it's not in this case. So this answer does not work. It's an extraneous solution. But if I plug in 4, it's 3x, so 3 times 4 is 12, plus 4 equals x. Does the square root of 16 equal 4? And yes, it does. So one of our answers now, for the first time, we plugged it in and it didn't work. So always check them, especially if you're dealing with something involving factoring, or the more complicated problems, this can occur more often. So the next one's very similar. I'm going to follow the same idea. I'm going to see this radical as by itself, square both sides, and I get 5x plus 14 equals x squared. It's a quadratic, so I'm going to set it equal to 0, and I'm going to move everything over to the positive x squared. So I'm going to subtract the 5x, and I'm going to subtract the 14. That gives me x squared minus 5x minus the 14. Same idea with factoring. X squared here, negative 14. And the diagonal needs to add to negative 5, but it needs to multiply negative 14. So I believe that's negative 7x and a 2x. Top row has a GCF of x, x, I think that's a minus 7 and a plus 2. So x plus 2, x minus 7 equals 0. X equals negative 2, x equals 7. Again, notice, if I plug in a negative 2 right in the beginning, after I take the square root of a number, I'm saying it equals a negative number, which is not possible. If you do the math and plug in 7, just so you know, it does work. 5 times 7 is 35. 35 and 14 is 49. The square root of 49 is 7. So 3 and 4 are new on it, so I would maybe keep an eye on these, look over them when you're going through it, make sure you're set on the homework for those. Now, the next part deals with what happens when you have more than one radical. And these are a little more complicated for it. But it's the exact same idea that we're dealing with before. Your job is to move the radicals to opposite sides. And then you're going to distribute on it. Now, this one's not bad. If I decide to pick a radical, and you pick any one you want, I'm going to pick this one because it's right there on the left side. I wanted to get it all by itself, and it is. If I put a parentheses around the left side, and I put a parentheses around the right side to square them, the entire left side, the entire right side, the square and square root cancel. Even on this side, this radical is all by itself, and so that's going to cancel. I'm going to get 3x plus 15 equals 2x plus 8. This one's not bad because both radicals were isolated. So I'm going to subtract the 2x. X plus 15 equals 8. Subtract the 15. X equals negative 7. But I need to make sure to check my answer. So 3 times negative 7 plus 15. That is negative 21 plus 15, which is negative 6. And then on this side, 2 times negative 7 plus 8. Negative 14 plus 8 is negative 6. And now really you're going to say, well, are those equal to each other? And you want to say yes. Because, well, they are. But I don't like that there is a negative number inside the radical, because you cannot have that. It is impossible to take the square root of a negative number when we're dealing with this, so therefore that does not work. But that was our only answer. So since there's no other options, this one is no solution. Again, always check your answer, but this time you better make sure it works for both. So let's try this one. Now this one's a little more complicated. The radicals are on both sides, so we need to make sure we move the radicals to opposite sides. So I'm going to choose this one because it's positive. And I say positive because it has a positive coefficient out there. It's just 1. I don't like that negative there, so I'm going to move that radical to the opposite side. The same way I would move any object, I'm going to do the opposite operation for it. So I'm going to keep this square root of x plus 10. But I'm going to move this minus square root of x minus 6 to the other side by adding. So I'm going to do 2 plus square root of x minus 6. Well, a little more complicated looking. However, let's think in parts. Is this radical isolated? Yes. Same as it has always been across, no matter which problem we've been dealing with. The radical is isolated. The radical is isolated. The radical is isolated. The radical is isolated. So it's isolated. So our job is, when it's isolated, is to put a parentheses around the entire left side and square it. And to put a parentheses around the entire right side and square it. And that's why I've been trying to say it that way. The entire left, the entire right. The left side's the easy part. The square and the square root cancel, and I'm left with just x plus 10. The right side, that's the more complicated part. But remember, to square something means to multiply by itself. So what I'm going to do is I'm going to show the multiplying by itself, and I'm going to set it up using the boxes. And you're going to see why. Because there's these radicals, there's so much that you have to look at. What do I combine? What cancels? I am going to set up the multiplication like this. And that's going to make it a little bit visually easier for me, and we will do it in green. A little bit easier for me to see what's going on. So to square something, really just draw a square and label the outsides with those dimensions. And let's fill it in. 2 times 2 is 4. Well, that was easy. Now if I'm doing 2 times this radical, that's actually not bad, because the 2 is just going to go in front of the radical. I have 2 of those radicals. So I'm going to write it as I have 2 of those radicals. And the same thing with this 2 down here is that 2 is being multiplied by the radical, so I have 2 of those radicals. So that's not too bad visually. But what does this cell say? You have this radical times itself. Well, that's kind of what this is telling us. Any radical times itself just cancels out the radical. So I'm just left with whatever was inside. So let's figure out what we have. And we'll kind of look at combining. I have all by itself an x. So I'm going to write down an x. I have a 4 and a negative 6. So I'm going to write down minus 2. I have 2 radicals, and I have 2 more of the same radicals. So I have 4 of those radicals. Again, you may think it's complicated, and I'll tell you it does. It visually looks complicated. However, we can think about it for a minute. Is if my job is to isolate the radical, I'm going to need to subtract this x over, and that's going to cancel it out, which really makes our problem not look too bad compared to what we dealt with before. Is I have this radical here. So I'm going to isolate that radical, And I'm going to add the 2 to make it a 12. I'm going to still need to isolate that radical by dividing by 4, which gives me a 3. Now I'll write it back over here. Square root of x minus 6 equals 3. Now that the radical is by itself, I can square both sides. The square and square root cancel. X minus 6 equals 9. X equals 15. Now your job is to check your answers. And by the way, if I do 15 and 10, 15 minus 6, so square root of 25, square root of 9, does that equal 2? Yes, it does. The more complicated part, and we'll do one more example of this, is the squaring both sides. I mean, right here is complicated. Now, your answer, I gotta tell you, after you combine like terms, you go, oh my goodness, x plus 10, x minus 2, 4 square root of x minus 6. You get freaked out. There's a lot of x's. But realize that x went away really fast. And you were left with a problem that was no different than that one. So when you have two radicals, here's what you need to realize. Your job is to get rid of both radicals one at a time. And that's why you isolate one radical by itself. Is that's going to cancel out that radical right away. Good. The next part is the part that is more complicated, but we're going to organize it visually to help us see what's going to combine. And that allows us to have only one more radical left that we can get rid of. And this on the outside should cancel out for us to make it a little bit easier. So let's just try out this one. This radical is all by itself. I like it. It's by itself. I'm good. I see there is another radical on the other side. I'm not going to freak out over it. I'm going to think visually about organizing. So the entire left side goes in parentheses. The entire right side goes in parentheses. The radical and the square on this side are going to cancel. I'm going to give myself some room because the left side is the easy side. The right side is the more complicated side. However, what does it mean to square something? Well, let's draw a square. And let's label the square with our dimensions. It's going to be 7 minus square root of x and 7 minus square root of x. And again, let's do the same thing. So the coloring matches. We'll color this into the green. And let's just see what happens. 7 times 7 is 49. And again, you might go, oh man, I got to do 7 times this negative radical 6. What do I do? It's not too complicated. You just put the 7 as the coefficient. So it's really a negative 7 radical 6. And the same with this 7 and this negative radical. You're just going to write it as negative 7 times that radical. Now do be careful. A negative times a negative is a positive. So the negative and the negative do multiply to give me a positive. And I have this radical times itself, which is the same as what we have over here when we squared. And all that does is it cancels out the radical, and you're left with whatever was on the inside, which just happens to be x. So let's start combining on it. I have this 49 all by itself, so that's good. I have this plus x all by itself, that's good. I have a negative 7 times that radical, and a negative 7 times that radical, which is a negative 14 times that radical. Again, let's see what happens here, though. A lot of x's, but how many radicals? 1. We know how to solve an equation with one radical, and that's get that radical by itself. Doesn't matter what's all over here or here. The job is get this radical by itself. Well, let's see what happens when I do that. I'm going to get rid of this x. So if I do it to the right side, I do it to the left side, and look at that, the x goes away. Beautiful, I only have the x inside that radical now. So now I still need to isolate that radical, subtract the 49, and that's going to give me negative 56 equals negative 14 square root of x. Still need to get that radical by itself, so divide by negative 14, 4 equals that radical. So I have square root of x equals 4. Now that the radical is by itself, square the left side, square the right side, x equals 16. And if I check my answer, just so you know, I will get 16. It does work for them. The more complicated ones are the one with 2 radicals on it. So maybe go back through the video, start back up with this problem, listen to it again, work on some of the homework. Feel free to contact me if you have any questions. And the next video will deal with the